Ohm's law. Ohm's law, it gives the relation between electric current and electric potential difference. To conduct the Ohm's law activity, the required material are this voltage supplier, and it is also called battery eliminator. Here we no need to use batteries, dry cells. Instead of dry cells, we can use this battery eliminator. So we can change the potential difference supplied by it by turning this knob. As you can see here, we can have different voltages like here 0, 2, 4, 6, 8, 10, all the way up to 12 volts here. So this supplies DC voltage. And here voltmeter, and this is ammeter, nichrome wire. These are the required material to perform the activity. So this is a circuit diagram of Ohm's law. So given in the textbook. See here. So battery negative terminal is connected with negative terminal of ammeter, and positive terminal of the ammeter is connected with the your iron spoke, and this side positive terminal of the battery is connected with the other end of the iron spoke. Here voltmeter is connected parallel in the circuit. Now let's take a look at our setup here. As we have seen in the circuit diagram, here negative terminal of the ammeter is connected with the negative terminal of the battery, and positive terminal of the ammeter is connected with the one end of the nichrome wire, and positive terminal of the battery is connected with the other end of the nichrome wire. Here voltmeter is connected. The positive terminal of this voltmeter is connected with the positive terminal of the battery, and the negative terminal of the voltmeter is connected with the negative terminal of the battery. So this is a setup to conduct the Ohm's law activity. Now I am going to switch on the battery eliminator. See here, the knob is at 0 here. As you can see, the voltmeter shows 0, and the ammeter also shows 0 here. So voltmeter shows 0 voltage, ammeter shows 0 amperes. This means when the potential difference across the wire is 0, the current is also 0, since potential difference is needed for the flow of current. Now let's increase the voltage to 2 volts and check the readings in ammeter and voltmeter. See the reading in ammeter. Here the least count is 0.05. How many lines it is showing here? 10, 11, 12, so 13 line indicating here. 13 into 0.05, so that means 0.65. Ammeter reading is 0.65. See the voltmeter reading. The least count is 0.1 here. It is 21st line indicating here. 21st line indicating 21 into 0.1. That means 2.1. Voltmeter reading is 2.1. Ammeter reading is 0.65 amperes and voltmeter reading is 2.1 volts. Now increase the voltage to 4 volts and check the readings in ammeter and voltmeter. Observe the ammeter reading here. Ammeter 23rd line indicating here is 23 into 0.05. That means 1.15 amperes. Observe the voltmeter reading here. It is 3.6. Voltmeter reading is 3.6. Ammeter reading is 1.15 amperes. Voltmeter reading is 3.6 volts. Now let us increase the voltage to 6 volts here. Observe the ammeter reading here. Observe the ammeter reading here. So 34th line indicating 34 into 0.05. That means 1.7 amperes. Observe the voltmeter reading 5 volts, 5.3 volts here. 5.3 volts. Ammeter reading is 1.7 amperes. Voltmeter reading is 5.3 volts. Observe the V by I ratio here. So 2.1 divided by 0.65 is equal to 3.23. Next 3.6 divided by 1.15 is equal to 3.13. Next 5.3 divided by 1.7 is equal to 3.11. So we are getting almost equal value. That means V by I is equals to constant. So what can we conclude from this table? As the potential difference across the wire increases, the current in the wire also increases. Now we can draw a graph for this table. Current versus potential difference graph. We will plot the potential difference on x-axis and current values on y-axis. As you can see here, the graph is approximately straight line passing through the origin. This is a straight line graph we are getting. From this, the current is directly proportional to the potential difference. That means potential difference is directly proportional to the current at constant temperature. This is called Ohm's law. V is directly proportional to I. So here we are getting V by I. V by I value is constant. Here we are getting V by I value is constant.